Hello and welcome to lesson 9E. We're talking about polygon theorems today. We already know a lot about polygons and their solutions, but just to remind you, the roots of a polygon P of x are solutions to the equation P of x equals 0. So what are my x values when y is 0? Each real root is actually an x-intercept of the graph of P of x. And if R1 is a root of P of x, then x minus R1 is a factor of P of x. If a polygon doesn't have any real roots and its roots are imaginary, and therefore there'll be no x-intercepts of our graph. So let's see an example of that. Looking at this right here, we have a lovely equation, x squared minus 2x plus 2 equals 0. And I'm gonna ask you guys now to stop and solve that using the quadratic formula. So when you solve this, you should get that x equals 1 plus or minus I. That means you have two solutions, and they're both imaginary, and they're at 1 plus I and 1 minus I. And if you look, we have no x-intercepts, which means we have no real solutions to our graph. All right, moving right along. Here's example 1. They've given me the graph P of x equals x to the 4th minus 6x cubed plus 6x squared plus 24x minus 40 to help me solve this. Well, I know that I'm going to have solutions at my x-intercepts. So looking at this, negative 2 is an x-intercept, and so is 2. That means I have known solutions at x equals negative 2 and x equals 2, which means we have known factors of x plus 2 and x minus 2 of this equation. So now let's work through how we can actually use that information to help us. I'm going to start off by dividing my polynomial by negative 2. So I'm going to use synthetic division because we've got a leading coefficient of 1, so I'm going to put negative 2 in my box. And when I look at this, the leading coefficient here is 1, negative 6, 6, 24, and negative 40. That's a negative, I promise. And we're going to synthetically divide. I start off by dropping down the 1. 1 times negative 2 is negative 2. 6 plus negative 2 is negative 8. Negative 2 times negative 8 is positive 16. 6 plus positive 16 is 22. Negative 2 plus 22 is negative 44. Adding these together, I get negative 20. Multiply together, I get positive 40. And thank goodness I get a 0. Which means that we now know that P of x is equal to x plus 2 times, what is that? I don't want that. Go away. Times x squared, or x cubed, minus 8x squared plus 22x minus 20. So we've now partially factored this, but let's keep going. I'm now going to divide by positive 2. What's left over? So I'm going to put positive 2 in my box. And I drop down what was left in this line here. The 1, negative 8, I promise that's a negative, 22, negative 20, I don't need the 0, and we're going to synthetically divide. Drop it down, I get 1, 1 times 2 is 2, negative 6, negative 12, 10, positive 20, and a 0, which means now we can say that P of x is equal to x plus 2 from above, right? Boom. And then x minus 2 times x squared minus 6x plus 10, right? So this became these two pieces here. Well, so we've got some factors, but we're not completely done. I'm now going to take what's left right here and solve it further. I'm going to set P of x equal to 0, which means I can say that x plus 2 equals 0. Whoa, hello, man. x plus 2 equals 0, x minus 2 equals 0, and then this x minus 6x plus 10 also equals 0. So here we get x equals negative 2. Here we get x equals positive 2. Those are the ones we were expecting. But this guy doesn't actually factor properly. He is unfactorable, but I'm going to instead complete the square because I like completing the square and it's kind of easy. And it's a good thing for us to review. So I'm going to start off by x squared minus 6x plus blank equals, send the 10 to the other side, negative 10 plus blank. My next line is something squared equals something. Well, remember, this is x. We take half of this number here, which gets me minus 3, right? So we go half, then we fill it in up here with the square, that's plus 9. Then we balance plus 9. Negative 10 plus 9 is negative 1. So I have x minus 3 squared equals negative 1. Well, to solve that, I'm going to take the square root of both sides. So now I have x minus 3 equals the square root of negative 1. Remember, guys, is plus or minus I. So I get x equals 3 plus or minus I, which means that my solutions here, so my solutions are negative 2, 2, 3 minus I, and 3 plus I. Gets me 4 solutions, just like so. That's my answer. All right. Well, this actually leads us to a really nice theorem, and it says that if my polynomial p of x is of nth degree, then p has exactly n roots. Well, so that means if a polynomial is of 5 degrees, it's going to have 5 roots. And your degree is determined by the highest exponent you can find of x. So looking down here, if I have y equals 10x to the 7th minus 8, I have a degree of 7, because that's my highest exponent, which means we have 7 roots. Here, by equals x squared minus 4x cubed minus x plus 2 equals 0. My highest degree is 3. So my highest exponent is 3, so my degree is 3, which means we're going to have 3 roots. And down here, when I look at this, my highest degree or exponent is 5, so we have a 5th degree and 5 roots. So let's look at example 3. Here I have x cubed minus 125 equals 0. That's a 3rd degree, because that's a cube, which means we should have 3 roots or solutions. Well, when I look at this, this is the difference of cubes. So I can start off by factoring this guy at the very least. So my difference of cubes, this becomes x minus 5 times, remember square squish square, x squared, opposite sign, plus squish 5x, always positive sign, plus square the last, 25, okay, equals 0. Well, when I look at this, we've factored a difference of cubes. Now I need to figure out how to do this thing and get a solution for that. That is not factorable. It's never going to be with a cubic. So I think I'm going to plug him into quadratic equation because I already know that x minus 5 must equal 0, so x equals 5. That gets me one solution. This guy I'm going to solve with quadratic formula. Negative b, negative 5, plus or minus the square root of 5 squared minus 4 times a times c all over 2a, which gets me negative 5 plus or minus the square root of, this is 25 minus 100, which is negative 75, all over 2. Well, that means x equals negative 5 plus or minus 75 is 25 times 3. So I get 5i root 3 all over 2. So my solutions are x equals 5 from right here, yeah, and then x equals negative 5 plus 5i root 3 over 2, and negative 5 minus 5i root 3 over 2. So as predicted, we produced 3 solutions. All right, let's keep going. We also have a conjugate root theorem, and it says that if a polynomial has real coefficients and has a plus bi as a root, then a minus bi is also a root. So let's say that I know that a polynomial has roots of negative 5, 4i, and 1 minus 3i. There are some other roots. There's a root of minus 4i and a root of 1 plus 3i. So notice this doesn't apply to the real root, but it does apply to the imaginary roots. So at the end of the day, I end up with 5 roots, and that means we have a 5th degree polynomial. All right, so I want you guys now to try this one on your own, take a look at it, and see what you think it is. So those are your solutions. Now we're going to go in this process of working backwards. We spend so much time talking about how to solve things. Let's talk about how to take solutions and make them into equations. I know that we have a 3rd degree equation. So 3rd degree tells me we should have 3 roots with integral coefficients that has 3 and 2 plus I as roots. Well, that means there's also a 2 minus I solution that we're just not seeing as another root. So if I want to figure out the equation, that means at some point you had x equals 3, x equals 2 plus I, and x equals 2 minus I as your roots. So if I were to work backwards, that means here we should have gotten x minus 3 equals 0, and x minus 2 plus I equal to 0 as an equation. That should be in parentheses. And x minus 2 minus I equals 0 as one of your factors. So when we string these all together, x minus 3 times, I'm going to distribute that, so I get x minus 2 minus I times x minus 2 plus I equal to 0. I'm going to FOIL all of this out to try to figure out what the original equation was. And I'm actually going to start off, so we're now going to FOIL and then some. I'm going to start with these guys first. So I have x minus 3 times, this becomes x squared minus 2x plus xi minus 2x plus 4 minus 2i minus xi minus plus 2i minus I squared. Well, I'm going to simplify that before I distribute more. So he becomes, there's just one x squared. Negative 2x and negative 2x is minus 4x. The xi and the negative xi cancel. The minus 2i and the plus 2i cancel. So this becomes plus 4 minus I squared. Well, if you guys recall, minus I squared is the same thing as negative 1. So this way becomes minus negative 1, right? So that transforms here. So we really end up with x minus 3 times x squared minus 4x plus 4 plus 1, or really plus 5. But I'm not done. I'm now going to FOIL what I've got here one last time. So I'm going to take a minute and do that. And I get x cubed minus 7x squared plus 17x minus 15 equals y. I want you guys now to try this one. Keep in mind, I'll give you how to start. So remember, if you have a second degree polynomial, you're missing a second root. Well, if this is one root, this is the other one. You set them up like this. You're going to want to distribute the negative and FOIL. All right, guys, we'll complete the rest of the notes in class. Thank you very much.